Today we're going to look at nth roots and real exponents. I have 3 examples to do. So for the first one, we're going to find the nth root. So for the first one that we're going to do here, I have the negative square root of 169. So remember the square root, the implied number here is 2. So I want 2 numbers on the inside to be able to pull one out. So 169 is 13 times 13. So our answer here is negative 13. A second one along this line, we have the square root of negative 100. Now since our negative is on the inside, the square root of a negative number, we can rewrite this like such. We want to break it out even further. The square root of a negative 1 is I, and the square root of 100 is 10. So we can rewrite this as 10i. And one more for this section. We have the fourth root of 625. So this form indicates that we need 4 of the same number to be able to pull out 1. So I can rewrite this. So the fourth root of 5 times 5 times 5 times 5 equals 625. Since I have 4 5s on the inside, I can pull 1 out. So this equals 5. So the fourth root of 625 is 5. For our next example, we're going to simplify. So here I just have 1 to do. I have the third root of negative 27x to the 9. So this 3 here, so our cube root, we need 3 on the inside to be able to pull 1 out. So rewriting this, negative 27 is the same as negative 3 times negative 3 times negative 3. And x to the 9th, I can rewrite that as x cubed times x cubed times x cubed. Now I have 2 groups of 3. So 3 on the inside makes 1 on the outside. 3 on the inside is 1 on the outside. So I was able to pull out a negative 3x cubed. So the cube root of negative 27x to the 9th is negative 3x cubed. Our third example, again, we're going to simplify. The first one I have here is the 6th root of 6,400a to the 3rd. So for this one, since I have a 6th root, I need 6 on this inside area to be able to pull 1 out. So I don't know what the 6th root of 640 is, so the first thing I'm going to do is I'm going to break this down. So I know it's divisible by 10 since it ends in a 0. 10 goes into 2 times 5. And this I can do 8 and 8. And I'm just going to factor it out until I can get 6. Alright, so looking at my 2's, I have 1, 2, 3, 4, 5, 6, 7 2's. And I have 3 A's. Now if I have 6 on the inside, 1, 2, 3, 4, 5, 6. I can pull this and move it to the outside, but I can't pull anything else out. So rewriting this, I have 2, and then I have the 6th root of everything that's remaining. So 2a cubed. Alright, so let's do one similar to that. Alright, so for another example, I have the cube root of 16 over the fifth root of 4. So the first thing I'm going to do is the cube root of 16, I know that I can take some stuff out. So this is the same as 2 times 2 times 2. And I know that 4 I can't go any further, so I'm just going to leave that. So these three I'm going to pull out. So I have 2 times the cube root of 2 over the fifth root of 4. So now I'm going to turn my radical expressions into fraction exponents. So I have 2 times 2 to the 1/3, because I have 1, 2 on the inside, and my root here is 3, over, I want to convert this to 2 times 2, so I have a base of 2. So 4 is just 2 times 2. So on the bottom here, my base is 2, and I have 2 on the inside, and my root is 5, so 2/5. So now I have fractions, so I can combine those. So I have 2 times 2 to the 1/3 times 2 to the 2/5, divided by. So when I divide, I can subtract my exponents. So let's just go ahead and just subtract. Since my bases are the same, I can subtract my exponents since I'm dividing the fractions here. Now to subtract fractions, my denominators need to be the same. So I have 3 and 5. The least common multiple is going to be 15. So I have 2 times 2, 5/15 minus 6/15. So I have 2 times 2 to the negative 1/15. So rewriting that, I have this 2 is going to be in my numerator, and this 2 is going to be in my denominator because our exponent is negative. So I'm just going to write it here. So 2 over 2 to the 1/15. And that is our solution.